So let me go back and show you a bit of implementation details about a static search and UI search. Again, a static search is simply best for search, as we have seen in UCS. So it has the same working as the UCS. So again, there's nothing that will change in the best first search thing. But what will change is the fact that what we are using to evaluate our system. So again, let me just show you a very small values that we are using to demonstrate okay, what is the difference between static search or UCS. Okay, so what you're seeing over here, okay, if our search algorithm is UCS, then the comparator that we are using is just based on the cost. So the comparator is just based on the cost. If the algorithm is greedy, then the comparison is just based on the heuristic value. Okay, only the heuristic value. If the algorithm is star, then the comparison is between the sum of the heuristic value and the path cost. So that's the heuristic value and the path cost of x1 plus the heuristic value and the path cost of the x2, and that this is the simple idea that we have for sending the idea behind this thing. Okay, this is the simplest way of showing कि जनाब किस तरीके से वो काम जो है वो कर रहा होता है. ठीक है जी. Now let's take a look at some demo. So let me show you by starting by this the maze thing. So we are going to use the static search, and the heuristic we are using is the Euclidean distance. So let's start with the greedy search. Euclidean is basically the straight line distance between the green dot and the red dot, or any dot with the red dot, any starting. You can see greedy search is directed towards this part only. So बहुत ही फास्ट है. तो अगेन इट एक्सप्लोड ओनली 88 नोड्स. याद रखिएगा जनाब के if you look in the previous videos, breadth first search took about it took about 780 nodes, and the path length was 41, but it took about 88 nodes. It's very fast because of the heuristic. And if I change the heuristic to Manhattan distance is basically the difference between the rows and columns. So the column of this green dot minus the column of the red dot, and the rows of this green dot minus the row of this red dot have this absolute values and add them together. Then this is what will give you the strict value. So again, if we use the Manhattan distance, which is a better heuristic, you can see it's even faster than with the Manhattan distance. It expanded only 60 nodes, which is about 2/3 nodes जो कि इसने expand करी थी जनाब while using the static while using the Euclidean distance heuristic. Now, but the answer is not optimal, of course. The answer is still 40. It's not an optimal answer. So let's switch to static search and use the Euclidean distance. And see जनाब के if you compare this thing with UCS, you will find के static search is what an average of both greedy search and UCS. UCS was moving all around and greedy search was focusing towards the goal, but static search is somewhat in between the two. So you can see जनाब के the number of nodes are a bit higher as compared to a greedy search, but the answer is optimal. But as compared to BFS, it has explored only 1/3 of the nodes. It's very fast as far as from BFS, and optimal like UC. It is fast as greedy search, almost as fast as UC greedy search, but as optimal as UCS. It's something it's just between the both best of both. Now let's use another heuristic and see whether it helps. And you can see Janab the difference is remarkable. We have explored 1/3 of the nodes, and the path cost is still optimal. So again, the better the heuristic, the better the performance of the node will be. So this is something that you should note and make a note of when using search. Again, let me show you another maze. So with greedy search, and you can see now greedy search is moving straight towards the goal. It has nothing to do with the path cost. The path cost इसके पास 21 आई है, तो इसको कोई फर्क नहीं पड़ता because it is not अच्छा no sorry मैंने cost कम करी हुई थी. Let me replace this. So let me restart this thing. So you can see the path cost is 93 if the blue cost is 5. Okay, and you can see it's a very high cost as compared to what we can find with better algorithms. But if we look elsewhere, So let me use another heuristic. Let me use greedy search with equilibrium Manhattan distance. So again, the path expanded are almost same, but the path length is better. But the path cost is much higher because greedy search is only focusing upon the on the heuristic value, but not the path cost. But what about asterisk search? Asterisk search with greedy, sorry, asterisk search with Euclidean distance as a heuristic. So you can see in our case it is somewhat like greedy search as far as concerned, but the path cost is optimal. The path cost is only 27. The number of nodes are less than UCS, but the path cost is much better than what was found by greedy search. So if we change the heuristic, we will expect better performance. तो हमने nodes भी कम expand करी हैं, हमारी path cost अभी भी optimal है. This is a demonstration that shows you the worth of asterisk search with heuristic as compared to breadth first search, depth first search, or any other search. Okay. So another example, a slightly simple example, but that will show you the difference between all the searches. So let's start with BFS. BFS, you can see it's moving in every direction, and the goal is straight down its alley. The solution is optimal, of course, but what about DFS? So DFS is not going to be very efficient, but if it had started moving right, maybe it would have found the solution much earlier. You can see the cost that you could pay, but fast. So let's see these. Because the costs are same, then there is no difference between UCS and BFS because the cost is same for every node that we are expanding right now. That's pretty much same performance, but the greedy will be remarkably better, straight towards the goal, because just going toward the goal. And what about static search? So you will see कि जनाब static search will move towards. So let me switch to another. Again, you can see जनाब because simple algorithm it will find the optimal solution in both cases. But a slightly more complex thing will have you find different solutions for different things. Okay. So we have seen some examples of how a static search works. We're going to show you some other examples as well. But you can see over here, for example, if you have D is the distance from your goal and average over 100 instances. So you can see the difference between a static search with the better heuristic, and so you can see जनाब के IDS अगर depth 12 तक चली जाती तो तकरीबन 3 million nodes को expand करते हुए static with a good heuristic will expand only 227 nodes, and with a better heuristic it will only 73 nodes again. So this is what is the difference between you will get even for a depth of 24 the number of nodes are only 40,000, and with the better heuristic it's just 1651, which is remarkably well. So this is the advantage that you will get when you will use static search with a good heuristic to play with. So this is why the heuristic development is very important when you're using informed searches, because the performance of your search will vary quite a lot when you are using these kind of searches. So there are still very variants of static search that exist. So you can always go and play around with these variants. So अभी भी जो vanilla static search, it suffers from the exponential memory growth that it requires. However, some refinements have been suggested. One of them is जनाब additive deepening static search, where the cost are used to define the cutoff. Okay, एक cutoff को हम कहेंगे जनाब इससे आगे नहीं देखोगे, फिर आप उसको increase करते रहेंगे. Then you have this recursive best first search जो कि क्या करता है जनाब के एक f limit को लगा देता है, तो जो कि एक बेस्ट ऑप्टिमल ऑल्टरनेटिव पाथ जो है उसको अपने पास स्टोर करके रखता है, और अगर कोई भी नोड उस पाथ को आगे बढ़ जाती है तो जनाब फिर हम बैक ट्रैक कर लेते हैं. सो वी गो बैक एंड लुक एंड टू पास जो कि हो सकता है दूसरे बेहतर हो सकता है. वन अदर थिंग इज दिस इज ऑल्टरनेटिव मेमोरी बाउंड स्टैटिक सर्च एंड सिंप्लीफाइड मेमोरी बाउंड ए स्टैटिक सर्च जो कि तमाम जो कि यूज़ करे जाते हैं प्रैक्टिस में to enhance the efficiency of static. इससे एक सच बड़ा पॉपुलर एल्गोरिथम है. आपके वीडियो गेम खेलते हैं उसमें एनिमी आपको तलाश कर लेता है, कोई गाड़ी अपने से तलाश कर लेती है, एंड ऑल दीज थिंग्स आर एग्जाम्पल जहाँ पे स्टैटिक सर्च जो इसको यूज़ करा जा रहा है. इट्स अ वेरी पॉपुलर एल्गोरिथम एंड आई वुड encourage you to implement these things in your program exercises जो कि आपको मिलेंगे. Thank you for your attention. Shall we see each other in the next week. Allah Hafiz.